So,
Oh. Come over, buddy.
a number of people claim that the inverse of the x cubed function was plus or minus cube root of x. Now, I'm glad that you're aware of the plus or minus, but that only applies to even powers. Doesn't apply to odd powers, because an odd power of a negative is still negative, right? Whereas an even power of a negative would be positive in all circumstances. So even power functions are not invertible. You have to choose a branch. Odd powers are invertible. They're one-to-one. You know, they go from down here up to here. They're totally one-to-one, right? So there are a number of things that you just need to think about, and it's easy. I think just about everybody that did this will understand. And if you didn't do it, understand that you really don't want to do it. So what the way this occurs, you got y equals x cubed. You reverse the coordinates, you get x equals y cubed. Well, actually, let's do the steps of this, because I'm not sure the way people wrote it down. People just wrote that y equals the cube root of x without actually using the laws of exponents. Okay? And if you're not using the laws of exponents, you're taking a chance. What's this mean? This means y cubed equals x. How do you solve this? You solve it by raising both sides to the 1/3 power. Okay? And you get y equals x to the 1/3, and that is, of course, what the cube root of x means. And if you don't know how to go back and forth between radical notation and exponential notation, then you're going to have to learn several new laws of exponents. Okay? You don't really want to do that. And the laws you have for exponents only apply to the exponential form of this expression. Okay? Now, with practice, you see how that works, but if you're not thinking in terms of what the laws of exponents tell you, you haven't practiced enough. And if you haven't practiced enough, you want to write down every step really carefully until you don't need them anymore. Okay? Instead of doing it by magic and superstition, which will lead you to things like this. Okay? Now, we also want to see why you have a plus or minus in the square root in terms of solution to the equation, okay? But we'll see it. Now, that's one instance. Plus or minus the cube root of x would give us plus or minus the cube root of -1, right? for x equals 1. For x equals -1. But if we cube plus cube root of -1, we get -1 cubed with a plus, right? Because if you cube a plus, you get a plus, right? But if you cube the negative of something, you're multiplying a negative by a negative by a negative, right? So you get the negative cube of that thing. And the cube of this thing is -1, so you get 1. So if the inverse function was plus or minus the cube root, or if the inverse relation was plus or minus the cube root, and you tried to apply it to -1, you get one answer from the plus, and you get another answer from the minus. Okay? Now, bottom line is, you don't do that with odd powers, okay? And again, the reason is because odd powers of positives give you positives, odd powers of negatives gives you negatives. Whereas even powers don't do that. So if you have like y squared equals x, you do this, but it only applies if x is greater than or equal to 0. Okay? Because if x is less than 0, you can't do its square root. It's not defined. It's not a real number. I mean, it is defined as a complex number, but it's not a real number. If x is less than 0, then y has to be the square root of -x. Okay? So you get two branches of an inverse function, but you don't get an inverse function. But over here it's just fine because you can take the cube root of a negative. You can take an odd root of a negative. You can't take an even root of a negative. Okay? So that you don't have this restriction when you take a 1/3 power. Doesn't matter if x is positive or negative, you can take it. And the other thing is, you know that your graph of x squared looks like this, and any positive power function has that sort of shape. It just gets flatter and steeper, okay? The inverse function, or the inverse relation for this thing, if you reverse all the coordinates, it's this, it's not a function, right? This is. This is 1-to-1. This isn't. And odd powers are 1-to-1, even powers aren't 1-to-1. Okay? So you want to ponder that a bit.